The short session is open for discussion from the audience. If anybody's got any questions, but I've got a couple on deck here. The Faustini is really interesting. It's a pretty challenging illumination environment, but it's also got a really great potential for South Pole Aiken materials, which is such a gigantic science question, right? Um, do either of you want to comment on a really, let's say, fundamental driver for why Faustini should really be in the mix? And we'll come back to the question of radiation and illumination challenges later. But um, anything that rings really strongly for Faustini.
You
Go
want
ahead,
to
Julie.
start first, Julie?
Hey, yeah. Um, well, personally haven't looked at every site in that much detail. So to necessarily put Faustini on pedestal versus another site, but the area would be a place where you could go to get a variety of materials from the for sampling the impact events that have occurred and trying to get the stratigraphy of the related craters in the area. Um, so that would be you're right on the rim of Faustini. So if you were up on that peak in the ridge or on the rim, you some of those boulders you could feel pretty confident about knowing where they came from. There's also that fresh crater, right? So that's a really nice opportunity. It's a fairly large fresh crater. It's a simple crater, so it's not huge, but it does expose a lot of less more recent material, so it's less exposed, and you can compare that to other materials in the area. I think also some of the impact ejecta that I've seen strewn across the region is likely to come from Shackleton, um, or possibly another source, but I think it looks like some of it is at least young enough and its degradation state is such that uh, it seems to be more of a younger age, which would make sense with Shackleton. Obviously, that's preliminary and more work should be done. But besides all the great impact story that's there, there's also the volatile story. This one has a variety of PSRs that are accessible. Um, they're not all large ones, but there are a variety of small ones, and being able to access a number of them lets you test things like our knowledge of models of volatile stability and access potentially different types of volatiles between different locations. Um, Also, the fact that this place is not illuminated, which makes it maybe challenging for mission planning, also kind of benefits the volatile story. Um, so, one thought would be like if you go there, you know that these volatiles have been shaded for longer periods of time. So, there's a lot going for it in science. So that's kind of
Yeah,
where somebody will have to make choice of how that fits into the mission planning, then I guess.
yeah. You beat me to my next question, but I, Caitlin, do you want to add anything?
Yeah, just to reiterate, I just um, the volatile story here it would be quite interesting, especially since there is a younger crater here, relatively speaking. So knowing the ejecta and the rim behavior between the Faustini versus this younger crater too, it's how does that work in with like buried volatiles as well? You're having that consistency of shadowing effects and illumination, but having a disparity between your crater ages slightly can also affect how your volatile behaviors are too.
Yeah, there had been a question in the chat from Dr. Rubio about the sampling of young craters and blocks from Faustini as a question of uniqueness. Is there anything that's tremendously unique about those sampling those craters, which I think you might have just hit on burying volatiles and things like that in a very cold region. Um, uh, but I wanted to expand on that and figure out if even if it's not a unique place, does it make Faustina a really good alternative landing site? If the illumination conditions are such that it's very difficult to get to, but it would be, right there in a sweet spot for an alternative landing site. You guys have any thoughts as to the uniqueness of Faustini, or as an alternative site?
Yeah, I mean, it strikes me as a little bit different than some of the other sites like Connecting Ridge, which have these long, narrow um, ridges for exploration that are up at really high elevations. Whereas this site there's this really small ridge, and most of it is more of the crater, um, a Munson crater kind of ejecta area. So it's lower elevation. The last slide I showed had an oblique, which kind of gives you perspective of like how it fits into the terrain. So you can kind of see in that image like Shackleton and its neighbors were up at higher elevation, and then like around it everything seems relatively high. So I was actually a little surprised that this one was in the 13 in some ways, because um, they were mostly looking for peaks of illumination as candidates. So, but this one
Mhm.
is interesting because there's a lot of terrain that's accessible, and you're not really confined to just that little narrow ridge.
Yeah, for sure. It all boils down to accessibility too.
Yeah.
That at least that there's, if anything, even if this is not a site in region, if it were to be a backup, at least there's still stuff to do on different levels here. So, like I said, radiation environment that we're sorely lacking. There's some minor tectonics here and fault structures. There's volatiles here. There's crater science that you can do here as well. So it's got a plethora of stuff that can keep us busy, if not a priority.
Well, I think a strong case can still be made for, SBA material and the volatile story, and um, but it is overcoming this logistical challenge from the illumination. But you just touched on my next question, which is this radiation environment, and so I hadn't been familiar with this, and I was, well, I guess, is there a way to, let's say, overcome the scariness of Faustini from this radiation perspective, or is it just a question of we don't know enough and we need to, figure out where Faustini fits into the story of radiation environment across all the landing sites?
Either way, we're going to have to be diligent in our radiation environment on any site, no matter what. So those maps are quickly being made now and hopefully used for decision making. In that regard, it's honestly just observing the sun. When are we going to that site? Make sure that are we at solar minimum versus maximum? Are we expecting any major solar events, flare events to pop up? In which case, do we have a contingency plan for our human activities to run inside, just run inside and duck and cover. So we've already would have had to have done this anyways, and we certainly have contingency plans for our ISS astronauts too, and they're way more exposed out there. So with that said, having these maps ready for decision making will be good, but it is something that we're going to have to really keep that in mind when making a decision.
Yeah, it is one of these. It's just another factor to add into the mix. Like illumination is a big, strong driver for what time of year you can go. Solar activity a little bit more difficult to predict. But then you wonder if it's a strong enough discriminator, to be, under reasonable consideration, or if, yeah, if it just looks as scary as it does, but it's not necessarily that harmful to the crew.
True.
Um,
And in that case though, it's we still don't really know about the radiation or even plasma environment. at the poles either.
Yeah.
So having all this data, no matter what site we're at, is going to help improve that level of safety.
Would either of you have any thoughts on the science driven by this both less frequently illuminated region and potentially somehow more radiation intense environment for things like space weathering or understanding the orbital or the maturity of the soil or anything on those regards? Very quick answers if you have anything. I think it's just more
I
fun.
mean, I think we might need some direction as to what is being prioritized for some of these, because, like you said, there's competing factors of illumination, visibility, radiation dose, desire to access volatiles, and some of those things. You can either go one way or the other. It might be hard to get all of them with this first mission, though.
I can imagine a very complicated matrix,
Yeah.
figuring out where, when, and how. Okay, I think that'll bring us to the end of our Faustini discussion. Thank you very much, Dr. Stopar and Dr. Ahrens.